Welcome to the test set. Here we talk with some of the brightest thinkers and tinkerers in statistical analysis, scientific computing, and machine learning, digging into what makes them tick, plus the insights, experiments, and OMG moments that shape the field. On this episode, we're joined by Emily Riederer, who I think has the distinction of living in that sweet overlap between Python, SQL, and R harder than anyone else I've ever seen, and is a data science manager at Capital One, and apparently listens to the test set, but is not planning to listen to this episode. Welcome to the test set. I'm Michael Chow, and I'm joined by my co-hosts, Wes McKinney, who's a principal architect at Posit, and Hadley Wickham, who's a chief scientist at Posit. And I'm so excited to be here with Emily Riederer, who is a data science manager at Capital One, and I think a sort of like icon in the R, Python, SQL community for just putting out so much interesting work in this intersection of Python, SQL, and R. So like recently the article Python Ergonomics and some talks around that of how to have a workflow that our users love in Python with things like pollers, and dbt-plier, which was a plugin for the SQL framework dbt, which was a really interesting sort of cross-section of ideas. So Emily, thanks for coming on. So happy to have you.
Oh, yeah. Thank you so much for having me. I've loved the pod so much so far. I have not missed a single episode.
Yo, I'm so glad.
Honestly, the biggest downside of being on a podcast is I was thinking about it and I'm like, ooh, the next one that comes out, I'm not going to want to listen to.
Yeah, are you going to listen to your own? I feel like,
oh my goodness, no.
You can't break the streak, you know?
Never.
So I think people will be really interested to hear sort of your journey through languages like R, Python, SQL, and the things you've put out. But one interesting question I thought might be good to open up with is maybe just on the role of SQL kind of over the years. Since I know you started doing a lot of R work, and folks here have done like a lot of work in SQL, whether it's like dbt-plier, which translates like dplyr in R to SQL, or ibis, which translates Python to SQL. Emily, I'm really curious to hear like what was your journey into SQL like?
Very abrupt in some ways, because I think if I think about my educational background, I was in a relatively like theoretical stats program, so could prove like asymptotic convergence of a lot of things, had very little experience with real world data until I get one of my first internships. I'm asked to make a customer profile. I take the average of customer incomes and I'm like, we're all rich. But we were not rich. I was just averaging in all the 99999 encoded default values. So that was my first introduction, both to databases, to SQL, and just like the vagaries of real world data. And I think that had been like, was also kind of jarring because I was under this whole illusion of like, oh, data is this like ground truth where we can like figure things out about the world. And then I entered into this world where like data is this like kind of source of chaos that you need to control. But then kind of coming into industry, I think SQL was one of like the main tools for the trade. The only way to kind of like access your data before you could get in there with something like R or Python. And pulling then from just like kind of a single brush I'd had in college with kind of database design and data modeling and normal forms, I think just something about that combined with the tidyverse just so kind of like clicked in my mind of like, there's actually a real art to how you like set this thing up, how you like get the data out. They can really just like set you up for success.
Yeah, it feels so real that like moving into a business, like going to work and hitting like SQL and realizing that there's like a process to get the data out. Yeah, Hadley and Wes, I'm curious your experiences with SQL too, where you both kind of, it seems like ramped up your SQL involvement at some point.
I mean, I will say I've been in an active, like, I think calling it a war against SQL is maybe putting it a little bit strongly, but I've definitely engaged heavily, and I think as has Hadley, in building tools so that humans write a lot less SQL. And I've often felt that SQL is, as a language, it's clearly not going anywhere. It's the lingua franca of databases, but it's also a little bit like assembly code or Fortran code. It doesn't have a lot of the modern niceties of a real programming language, like functions, like reusable code, like code that you can refactor and reuse. And so like early on in my career, I was a bit scarred by hundreds and thousands of lines of copy and pasted SQL queries that, there's no tests. And so, you were dealing with these like highly brittle, very complex, hundreds of lines, many pages long, 10-page long SQL queries. And, the reality is like SQL is really alluring in the sense that like it's declarative, writing simple SQL queries is easy, but complex business logic, especially in the financial setting, ends up being rather subtle and with a lot of complexities. And so I found myself like making the same kinds of mistakes over and over again and seeing other people make mistakes. And so I felt like if only, if we could essentially abstract away the unpleasantness of SQL and make it easier for humans to write, essentially author SQL indirectly and to avoid many of those common errors, then we would be doing humanity a great service.
I guess I actually started with databases. Like I did SQL before R. So my dad, a lot of his work involved databases. So we had like dinner table conversations about like relational data and Codd's third normal form. And when I was in high school, I guess starting from like age, I don't know, like 15, I like made access databases as like my part-time job. And I did some like database documentation as a part-time job. Which is kind of like crazy looking back at it now. Like that's really how I learned to program, was in like Visual Basic for applications. Like that was my first real exposure to programming, real exposure to SQL. And kind of interestingly, like I've been working on dbt-plier lately, which translates dplyr code into SQL. And people, like dbt-plier has an access backend, and people file issues that it doesn't work. And the fact that like that is mind-blowing to me, that even in like 2025, people are writing R code to connect to a Microsoft Access database and like work with that data. That, I don't know, that's just kind of like mind-blowing to me.
Yeah, that's fair. That does feel like the business reality, that someone has like an access database somewhere that they need to wrangle, and it's like surfacing in these tools. Yeah, I'm so curious, like, so Emily, like your journey into data science and how you encountered a lot of these things. Do you mind explaining a little bit just how you became a data scientist? Like, what did that journey look like for you?
I mean, in some ways, like, I think I have like a very boring or traditional data science background in some ways, but in like, I think there's a different read where it's like kind of funny because at every step of the way, I knew what I wanted to do. I probably didn't know the right reason why I wanted to do it. So kind of started out like in college or in high school, took my first stats class, just like had been a math kid, figuring out what can I do with math, and just had this like idea of this being like this amazing truth-seeking, like applied way to like do math in the real world, I think. And then over time, kind of like there was all this hype around big data and data science, and it seemed like a natural progression into the field. I think, I mean, definitely going in, I didn't actually know probably like so much of the things that were true about it. The data science is like so much more of an art than a science, that it requires so much more engineering skills, and you'll like never once again in your life feel the certainty of math, which is probably the thing I liked about math in the first place. But yeah, like I think in some ways like very linear journey, but it's kind of funny to me looking back on how completely on false pretenses.
I think I saw you mention like your early work was more around like modeling and using R for modeling. Is that?
In my time at Capital One, my current employer, I've really worn like 3 very different hats, which also like maybe kind of mirrors some of the different tools in the data space. Started out working a lot more on problems of like measurement, causal inference, understanding, the values of different like levers you could pull, and customer lifetime values. And that's like a lot more exploratory type work, a lot of more like visualization and modeling, and just like being a lot more intimate with kind of like both the data and the business. Then kind of like took probably a sharper right turn to move upstream and spent like a number of years in more of the tools and data stack. So thinking about building out data pipelines or in Python tooling for kind of a broader community to use. And really just like spend a lot more time thinking about how does good coding practices, how does automation, how does good engineering really enable better analytics before moving back into the like core traditional like machine learning modeling type space.
I feel like the switch from like the modeling to the data engineering is so intriguing. Like, what was that like? Like, what were the sort of tools you switched into and things you used?
In some ways, I like fell into that one pretty like organically, even though the like actual roles seem on paper very different. I think in part for what we were talking about of like you join a company and suddenly like you find out like in school the data sets you were working with was penguins, or I'm old enough I'll date myself and say iris. It's just like embedded in some nice little toy data set. But you know, I mean, so much of your work, even if you want to do that really like exploratory deep analytical work, is around getting the data. And I think I both had kind of Wes's reaction of like, I'm working on this like huge, long, multi-page SQL script, and there are all these subqueries and nested tables, and I'm trying to draw it out on a board like the Always Sunny in Philadelphia meme. But at the same time, like, there was something to me that was like so interesting about both how like, and like, I think I was feeling all the pain points so closely that like, I can't focus on the thing I want until we get data right. So started to get like obsessed with kind of like column names, data quality checks. How can you actually do like testing and macros and all the things Wes called out that aren't native to kind of SQL. So it's like spending a lot of my time outside of work trying to like understand, build out that part, as well as realizing like to really understand data. We talk about from a statistics perspective, like understanding the data generating process, but there's like a separate data generating process that's like the data pipeline process that is like the number one thing that predicts kind of what the data errors will be, what the failure cases are. So I think just kind of like fell in love in service of like understanding the problem in the last mile with thinking about the data. And then at the same time, the thing I was working on, without going into too much detail, I found myself kind of like repeating for many different use cases in a way that just like felt so anathema to me to just like how I saw people in like the our stats Twitter world outside of work, like building packages, sharing code, like easier to collaborate with someone in Australia than collaborate with someone in the same company sometimes. And I was like, that seems wrong, which is how I started like getting into like internal package development, tool building. So just like kind of thought I was doing it all in service of the analytical space, but more and more I found my like time and energy like gravitated towards these upstream problems.
And if you had to like break down for yourself, like at that time, like what a data pipeline is and like what are kind of the key pieces involved, like how would you kind of break that down for someone?
I mean, the most kind of, I guess, classic go-to paradigm that you can think of with that is something like extract, load, transform. And even probably before extract, there's a step we don't talk about a lot that's like logging or encoding of like somehow something that happens in the real world has to be turned into some digital signal. Then extract being someone has to go be like capturing that signal and getting all of the different data sets into one sort of centralized place in some sort of format. Depending on your field, maybe that's hitting up APIs, maybe that's working with vendors, maybe that's even being a field scientist and doing manual, like working a notebook and then punching it into a computer. But then once that's kind of like loaded into a data lake or a data warehouse, you still need to impose some level of like organization, which at a high level you can think about as maybe being more like organizing the files in your file system, but there are actually different conventions around that. If you're using blob storage like S3, which is more like literally organizing files on your hard drive, or doing it in a database where in some ways there are a lot more rules and constraints, but that helps you get a lot more stuff for free, like discoverability, some level of kind of like constraints and checks on internal integrity, all in service of getting your data kind of structured in a format that it's both easy to maintain, meaning easy to add, update, change to reflect the real world, and also easy for your downstream users to understand and use.
And is this the point where you started using like dbt more or in some of this stuff, or?
Down the road, I think a long time, but like I think dbt was like still really in its infancy at the point I started doing a lot of this. But this is definitely the point where I think started feeling very, very acutely on a daily basis the exact sort of pain points that dbt solves for. That like I could build kind of my own workflows for like, oh, how do I like, if I want to test some SQL code, maybe not harder to set up test cases than unit tests, not abundant to do that. I had some like crazy workflows like pulling data down into an R Markdown notebook from my database and, you know, kind of like doing a lot more round trips than necessary. Figuring out a big part of data pipelines is orchestration, which like I don't think you run into so much in analysis, but if you have like a lot of long running things, especially that depend on systems that aren't in your control, thinking about how do you make sure all of those, everything like happens in the right order, which is not a hard problem. There are a lot of great open source tools for doing that, but maybe not always ones analysts have at their disposal and fingertips to spin up the right infrastructure for. So I think like I just like had my elevator pitch for like the 7 or 10 things that were the biggest pain points of SQL. And then one day I was like just at the gym listening to like a data engineering podcast and heard one of the first like interviews, or I don't say first to me interviews about dbt. And I was just like, oh wow, they like these people happen to like be interested in solving like some of the exact same problems I've been thinking of, which I think like for a certain time in the data space was like a weirdly frequent feeling of just that sense of serendipity where like you'd be working about something or thinking about something, and then within a week somebody'd like put out a dbt, put out an R package, ask the exact same question on Stack Overflow, and it was definitely just like kind of serendipitously fell into it that I was having the same problem as a lot of other people.
Yeah, I found like when I like it took me a while to understand like what dbt was, like what was the like why were people so excited about it, until I kind of realized it's like an IDE for SQL plus the ability to write functions plus the ability to use like Git, and I was like, oh wow, that's like you didn't have that already for SQL. That's like crazy, and obviously people are gonna like love it now because like love this tool because how do you do like software engineering without like functions and version control? Like
yeah, I've realized it's like for that reason a very hard thing to make kind of the elevator pitch for, because it's, you know, I mean, if you turn somebody that like just has a couple of queries they're running and they're like, hey, what if you broke this into like 27 queries and added some YAML files in there, and they're like, oh my goodness, that sounds like terrible. But once you've like, I think it's like super easy to sell to like people that have like lived in the old world, but then people coming into it now, like I know there's a lot of talk of like dbt versus SQL and like anything that you take as like the base case, it's like you can see like, oh wow, there's still a lot of room for improvement here.
Yeah, if you like explain the pitch for dbt, it might actually sound kind of like more complicated. Like it's quite a bit you're asking the person to do. So if the person's already doing a little bit of SQL, it might be kind of like a turn off. But to Hadley's point, like all these things then bring like testing and version control and kind of like engineering practice.
And there's other things like lineage and like other, essentially stuff that provides insights and intelligence into data pipelines. Like otherwise you'd be essentially flying without instrumentation. Of course, now it's funny because like there at one point this whole ecosystem seemed very fragmented, and now it seems that everything is at Fivetran. So hopefully they'll, now that they're all almost many of the folks like SQLglot, dbt, all SDF, they were building the intelligence for data engineering, and they were acquired by dbt. So all the folks are working together. So hopefully I hope that will yield a more integrated and stack of tools that play more nicely together, and that people are happy to use. But I've met a lot of these folks, and they seem like they're all working to for the benefit of the actual users and making things better. So I'm hopeful.
The other thing I find exciting is starting to see like a little bit of innovation in the SQL space. Like I think DuckDB has like introduced a number of like SQL extensions where you're like, oh my God, like why has no one done this before? Like yet like everyone has this need. And yet like it's taken until like DuckDB to be like, hey, we're gonna create like something that's very like SQL. We're not gonna like throw it out and try and create something completely new, but let's just make a few little tweaks here and there to make it like a little bit more logical, a little bit more useful.
Yeah. And I think that's the number one weirdest thing of SQL as a language is like it's not one thing, but there's like a loose standard that everyone adheres to until they don't. And like I feel like that's like I've loved most of the changes they've dropped, and of course introducing things like column selectors, which I'm a very big fan of, largely thanks to dpt-plier. But at the same time, like it's a tough trade-off too, because I know everything like every time you deviate from the grain, it's like, yes, but it's also like slightly less interoperable.
SQL is really interesting to me because it's sort of like this pre-internet technology in many ways. Like, you know, SQL is like a spec. It's like this like an ANSI SQL spec, but you cannot actually get the spec without like paying for it. So I actually have like one of the few like books. I still like I have SQL 99, like complete really. Like this is the only resource I've been able to find that actually like explains how like SQL is supposed to work, not how like some specific database implements it. And I think that's, I don't know, I find that kind of bizarre. I mean, luckily, like I think recently, like Claude is like filling a lot of that gap for me. Like Claude seems to have this knowledge of SQL that I could never through Googling, I could never find the right website, but it must be on the internet because like Claude seems to understand it now. But I don't know, it's just really interesting to me as someone who's been like writing this translation layer from R to SQL, like to try and figure out what is SQL, like what's the official way you're supposed to do this, and like what do databases actually support, and like what are the kind of databases that are the like, you know, kind of growing up, you just you sort of assume whatever database you use the most of is like the normal database and everything else is weird. But like getting out of that mindset, being like, oh, okay, this is what it's supposed to be like, and every database actually does this incorrectly.
That is fascinating about the spec. I didn't realize that was so not accessible. Like, there's so many like fascinating topics in open source governance, but I've never heard of that. Like, here are the rules, but you can't see them.
I mean, you can get them, but it costs like $3,000 or something to. I don't know. I mean, maybe it's easier. Maybe I just never had the right searches, but that just, yeah, I found that like mystifying. Like, and kind of even just this idea that like, to me, like if I want people to like do something to like follow something I've written, like to me, it's like obvious you want to give that away for free. Like,
oh yeah,
you don't
I mean
like,
that's
charge people for
part
it.
of the like pit of success you talk about too, of just
Yeah.
get your stuff out.
And then yeah, and then I think, you know, some of the most successful database like Oracle and SQL Server, they're the ones that are most distant from the spec.
Yeah, it's interesting too, the spec, because it's so expensive. Like when I was working on SQL translation, question I had was like, if I bought this spec, would it just be a prescription, or would it describe databases as they exist? Like it was almost hard for me to tell, like, did databases follow this, or is it kind of a prescription that got.
I think if you read it, it's like also I think like if you were to read it, it's like actually extremely difficult to understand because it goes into a very, very high level of detail. And you actually want like something kind of in between. You want like the general, like what is this supposed to do, but not every single possible little edge case. Like if you've ever read like the HTML5 specification or any of these, like really to get like to just lock down every edge case so people can agree on like this is the way to do it. It's so much detail.
I mean, I think there was an aspiration to make it actually a standard, like in the sense that C++ has a standard and then compilers agree to implement that standard. So you can say, you know, C++ 14, C++ 17, C++ 20. And so I think SQL, they tried to do that, but then the reality was that the business needs of database vendors trumped conforming to the standard, and so they would introduce things that went outside the standard, or of course things like function names weren't standardized, and so every database has got different names for functions, and like some databases implement division differently, like whether you can divide by zero, like division by zero has like a prescribed behavior in the standard, but then some
that's the other
databases will
mind-blowing thing to me is like SQL doesn't, like in general, databases don't support proper floating point math. Like they don't follow, every, the way you expect like modular arithmetic and division and stuff to work in like R and Python and every modern language. Like SQL is different. Like you can't represent, like SQL in general doesn't have like a notion of positive and negative infinity or not a number. It's just like sort of fascinating that this like technology, like this sort of dinosaur technology still lives today.
Yeah. I think just to like circle back and flesh out something you brought up, Emily, is you mentioned selectors, and I wonder if it'd almost be useful to almost explain what a selector is, because it's kind of like it has been added recently to a lot of SQL implementations, but maybe you could talk us through like just what is a selector.
Absolutely. And I think that tees me up for a question I've always wanted to ask Hadley. So appreciate that. But so if you think about, I'll pander to the art crowd here to start out, but a selector is, you have a data frame, you have a bunch of columns. If you have, in fact, named your columns well in a standardized way, or if you think about data types, there are a lot of different like kind of identifying information you could use to grab out and act on a set of variables. So if you want to do some sort of mass data wrangling process, like say in SQL, maybe you want to take the average of every Boolean variable you have in your table. If you're doing that in SQL, you're going to be there a while because you're going to be typing like mean or average variable A, average variable 2, average variable 3. But in some of the more modern kind of programming languages with more flexible APIs, you can have these like really nice kind of selectors where you might say like, for all Boolean values, apply the same transformation. Or if you get a little clever with like naming columns in a standardized way, for all of my like variables related to this entity or representing an indicator, do this operation. So for kind of like large scale wrangling, it can just be a way to like write a lot like cleaner code, avoid a lot of like kind of typos or copy paste errors by consolidating your business logic and just applying or mapping it over many different variables. And I know the first place I saw this was in dbt-plier. I think now I know it's in Spark has it, Pullers has it, a number of different like SQL variants have it, Pandas has it. But Hadley, like I've always wondered, like, to the best of your knowledge, was dbt-plier the first tool that had implemented those sort of selectors?
I don't know. It seems like my recollection of this is vague. Like I kind of remember around this time, like kind of learning that, like one of the problems people have is that they have a data frame with like 800 columns and just selecting the correct columns is a pain. My vague recollection, and I did a little Googling that kind of supports this, is I think like Stata had some tools for variable selection I think that's where I learned about it from like Stata users. Like looking at the documentation for Stata, like it looks like it. You can say like here's a start of the range and here's the end of the range. Here's like all the variable. You can select all the variables with a prefix. So I think that's probably. I have a very vague recollection that maybe SAS has something similar as well, but yeah, I think that's where I think it came from like statistical software, which is kind of surprising because it does feel like this is something you feel the need for in like SQL all the time because you're just typing out like variable after variable.
I was just looking at Pandas to see if it had it, and I don't think it does. I mean, I haven't been super active in Pandas in a long time, but it doesn't look like it has selectors quite in the same way that dbt-plier does, or that DuckDB does now, for example. I think the IBIS team implemented it, and I guess like Pullers and IBIS have selectors similar to dbt-plier now.
I knew I'd done something similar in polars or in Python with pandas of just grabbing out the columns and doing some list comprehensions and throwing that back in, but I didn't want to say that was the best way to go. But I'm fascinated if it came from Stata. Like my main recollection of Stata from college is like, you can't have two data frames in memory at the same time. So I did not think of these bits as like bastions of user experience.
So interestingly, like I'm looking at the docs for this on the Stata webpage, and one of the things it mentions, like there's specifically like my kind of favorite selector in dpt-plier that like literally no one uses is called num range. And so you give it like a prefix, you give it like a starting number and an ending number, and it will generate. So you can say like, select me from X1 to X50 really easily. And like the Stata docs specifically say that there's no way to do that easily in Stata. So I don't know. I think that's kind of evidence for like, okay, I was like, well, Stata can't do this. Like, I think that's something useful and I'm going to do that.
You mean
And
there's
I,
like that's like spite like a response, evidence of a response. You're like,
but it's
they
also,
said
yeah, but it's
no,
also one of those
so-
functions I'm like, I think this is cool. I would have thought like people would use this, and like basically no one does.
Yeah,
Maybe I'll,
it's so fun. It's such a small, in a way, like such a small behavior, but it does seem like so, like it's so ubiquitous that it does make a big difference. That SQL users, and when I've had to type SQL manually, this idea that you just type over and over again the same calculation, say on, and just change out column names, is kind of mind blowing. So it is funny. Like selection does seem like a really simple topic, but it is kind of crazy how much it shapes the quality of life.
And I think even like for me personally, I always wish like, I feel like if that existed in databases natively, people would think about more like as they build their database is like names is something that can do a thing, and then think about those more carefully, like you would think about designing an API. I think, when you get into like kind of industry or production databases, it's like you get into all these things where there are like 10 different ways to like abbreviate account ID. So you'll end up with like 10 different versions of that and be mentally accounting which table they're in. But I think for me, it was just like a big aha moment of like, oh, like my column names can actually like do something if I'd like actually think of them as like part of the software.
And I think this is very much your column names as contracts post. Is that right?
Yeah, indeed.
Yeah, nice. And I feel like dbt-plier, so like your dbt plugin kind of like built on that concept a bit. Do you want to explain a little bit about that?
Yeah, exactly. So dbt plugins, packages, whatever you want to call them, are the answer to what kind of Wes called out about SQL not really having a native function interface. Again, I think that's something that's wildly data specific. Some do and some don't. But even the ones that do, it's not really great to use them because then you've just like loaded code to a database. It's not really version controlled. You can't really see what it does, can't access it that easily. But dbt, just I guess taking a step back, is essentially like a collection of SQL scripts, macros, and other files organized in a very specific way so it can kind of infer the dependency graph and execute. Sort of similar to how an R package is maybe just a lot of R files organized in a smart way, so the computer knows what to do with it. So they abstracted that then a like step forward more, where you can have dbt packages, which are kind of like data agnostic chunks of SQL code that you can then like kind of import and call as macros. They can be at the function level, they can be at the table level, they can exist in a lot of kind of different levels of granularity. So dbt-plier was kind of like an early-ish dbt package that I put out there that was essentially stealing a number of things I really liked about the tidyverse, but specifically around column selectors, and trying to like port that API into SQL to solve this exact kind of problem of how do I grab out a set of columns and how can I then like apply transformations on those in bulk.
What was the reception like? Because when I went to dbt's conference Coalesce in 2022 to give a talk, and they were kind of surprised that a person from RStudio came through. They were excited, but the one thing I remember is they kept saying like, Emily is our like representative from the art community, and they kept like they pointed to dbt-plier a lot as an example of kind of like a really interesting cross-pollination of ideas. Like what was the reception like? What was it like kind of going into that community?
I think it was interesting because I think there were people kind of going back to the point about it being like a simple idea, but that has legs of like, there are people that like got it, probably that had seen it before. I know there is one DBT Labs engineer at the time that really was like, knew a lot about R, had been part of that community, really kind of like latched onto it. You know, I mean, I think people that had like seen how it worked somewhere else kind of really got it. I think the thing I realized in retrospect was probably calling it like dbt selectors would have probably been like far more useful and informative for like discoverability purposes, since like dbt-plier is like kind of a shibboleth of like pre-limiting yourself to only having like the R part of the community having like any earthly idea of what you're talking about or what to expect from it.
Yeah, that's a good point. I feel like forever debate, the like, should I name it after the thing it like most resembles for me, or should I give it like a new name for these people like over here?
Yeah, and then like in my head it was like an homage kind of to like dbt-plier, which I'd also like used a lot, gotten a ton of value from. But naming is hard.
That makes me think of a question we've been struggling with that you might have some insight on, and that is like, as we're creating more packages where we have like an R version and a Python version, like what do we name them? Like, do we give them like, I think with like orbital and pins, we're like, okay, we're going to call the R package and the Python package exactly the same thing? Or do we do it like great tables, where we've got GT on one hand and great tables on the other? And I think there's another, I don't know if you remember, Michael, but I think there's another case where we're like, these are totally different names. Like, do you have any sense of like what do you think we should do when we're doing like one package, like the same idea but implemented in two places, in two languages?
That's a really interesting question because like I'm sure too you're also bound by different namespace availability in both languages.
Yes.
On one hand, like with Orbital, like I find it very satisfying of like, if I've heard about it in one language, then it's trivially easy for me to be like, oh yeah, I know they have that thing in the other language. But I do think, I mean, even with like GT versus Great Tables, like in a weird way, there's like a nice like mental name spacing to the fact that like, I know these do not like aspire to be at parity. The APIs within them aren't 100% the same. And like, I feel like it kind of sets my expectations right, that like, these are aiming at the same goal, but they may not 100% get there in the exact same way.
Yeah, it's interesting because like Orbital's a case where probably that like the API of Orbital is simple enough. You can it's basically the same for R and Python. But obviously the more complicated the package, the more it has to kind of diverge. Like you want a package that feels R-like, and you want a package that feels Python-like. You don't want to be like, oh, I'm writing R code in Python, or I'm writing Python code in R. That's
something I've so loved about Michael and Rich's work on both like kind of Great Tables and Point Blank and all. I mean, honestly, even like Plot 9, I feel like manages to get like that distinctly more like Pythonic feel in the Python version. And I do think that like something I think a lot about as I like kind of switch between languages is like, I'm well aware, like, I definitely write Python code with an R accent, but at the same time, like, is best, like, it feels so much, like, you're going to get so much further and have a lot less pain if you're, like, leaning into the conventions of the language you're in. So it's been fun from the outside looking in, I feel like, to see, like, where the design decisions are the same and where they do kind of, like, fork off.
I think R has had a lot of impact on Python as well. And if you look at, like, the API of polars, API of IBIS, and it's a much more like pipe centric kind of fluent API. And I think that's, people looked, I think a lot of people, myself included, looked enviously from the Python world into the R world, and that we were like, oh, wouldn't it be nice to just be able to refer to column names like inside of expressions and not need to like, sub basically, index into a data frame to be able to get a reference to that column to be able to do things and stuff like that, like the non-standard evaluation that you have in R that comes from its Lisp heritage. And so I think that the people in Python have tried to replicate like some of the flavor, or like the niceties of that, like the underscore operator and stuff like that. But still, it's hard to shoehorn that type of API into Python, which is like in many ways the opposite of non-standard evaluation. Like it's everything must be as explicit and obvious as possible. And so to try to do things like magically is considered unPythonic. And so that there's always been a little bit of a tension there of like, how do we, do nice things on behalf of the user, but like still make it obvious what's going on at any given time.
Yeah, and that feels like the kind of like it's almost like the spectrum of like, do we give these things the same name is like the very first question, and then like that reminds me of like the deeper questions of like, how do we even architect it so it feels Pythonic versus like has like an R sort of smell to it. How do we actually lean into kind of Python as a language? It seems so tricky to kind of strike that balance kind of on all those fronts. I will say for Great Tables, when we started working on Great Tables, which is a port of the library GT in R to Python, it wasn't available on PyPI, so that kicked off right away like the need for a new name. But what I appreciate about Rich is he was open to like, what if we just few people knew that GT stood for Grammar of Tables. So I have to hand it to him for being willing to just retroactively like rewrite history and pretend the acronym stood for Great Tables. I think actually few developers would be willing to retroactively change an acronym.
I'd actually forgotten that. Like in my head, I'd already translated. Yeah, like GT, that stands for Great Tables. I'd forgotten it was like Grammar of Tables inspired. Yeah, that's like perfect.
I didn't know that story, so that's cool.
Yeah, kind of freaky. But I do think on the name front, it's challenging because I think I'm biased, but I think it's hard. Like when you give something the same, I think when you give something a new name, it's a chance to really like speak just to that audience. And like really force yourself to address them kind of directly.
I mean, I do think one of the problems with the Python community is that they don't appreciate puns as much as the R community. So I don't know, like I think there's a lot of like R package names that like just so perfect for R and just like would not feel right in Python. I mean, the other big problem with the Python community is like not enough hex or not enough logos. Like people don't do logos for their packages. I'm like, what is this?
This is a serious problem. This is not a trivial problem, because I found like if you go to like try to give a talk about Python, you're like, I don't know what to put on the slide. You know what I mean? Like R, it's like you need a simple slide. You get hex sticker. But it's a struggle.
Yeah. I mean, that was Great Tables. I think we used a pentagon specifically to have a logo, but for it not to be a hex, which I know Hadley maybe objects to aesthetically, but
I don't know. I think there's like something perfect about like the Python package logo, like not tessellating the plane. It just feels like Python. Like
we don't want to tessellate.
Yeah, exactly. Like we're like, let's all fit together. Let's all the packages work together.
Yeah, I'm curious, Emily, how do you choose like the things you get into? Because I think that like digging into column names as contracts and like addressing the DBT community is so interesting. How do you kind of choose what you're gonna like, which threads you want to pull?
I think I've always like first just like really gravitated towards things that might otherwise frustrate me, but just like had so much curiosity of like, couldn't they be better? Like, don't we maybe need more internal packages? Or like, surely there must be a better way to like write this SQL code. And I think kind of like really being kind of like drawn to kind of like the little just like more paper cut everyday problems. I think it's just like left me with a lot of like curiosity and energy to explore things that otherwise would just kind of like drain you. And then I think that's just coupled with like, I love just like learning about kind of new tools, new algorithms, just like kind of squirreling away information that like it doesn't feel like I probably ever need to have, just as like save it as a nut for winter. And I think that was so easy, especially early in my career, was kind of like the renaissance of like our stats Twitter, where you just have like people just like, you could be on the fly on the wall for just like nonstop conversations of people so much smarter than you doing just fascinating things. And then just like very luckily just being able to do a lot of that pattern matching of like, oh, I have this problem. Oh, and then I heard about DBT. Or like, I'd really love to never copy paste this again. But I think there's a thing called that aren't markdown that exists. That I think is just like, it's kind of like, I'm curious about the things that frustrate me. And then I just have all these like tools that I want to try. And then sometimes I just like kind of get lucky pulling the right tool from the toolbox.
Yeah, it's so cool. And I do think it's so interesting where so much of this really shines in your blog, where you're often like stitching together tools, like multiple tools in really creative ways. And I think something that like came up when preparing for this is like imposter syndrome. Cause I know that like with blogs or when people put themselves out there, like that's can be a really big challenge. I'm really curious, like your take on like what that looks like for you, and maybe advice you'd have for people that are like blogging or putting tools out that might feel a little imposter syndrome.
Absolutely. I mean, like, even preparing to join this podcast, I was like, what have I done? I could just be having a nice Friday afternoon. And I'm talking to like 3 luminaries of the field. But I mean, I think in some ways, I think it's something that in some ways you really have to get comfortable with, because if you aren't in rooms with people that you feel like you have a ton to learn from, that's kind of sad, and you're probably also in the wrong rooms. You know what I mean? Going back to like, I think the last question of like the way I learned, which is getting to like absorb all of this amazing content from other people out there. And like, if you weren't part of the conversation, you weren't going to get to kind of like learn and encounter those things. So I think like I've always like somehow managed to like get myself like in a lot of places that I really had no business being, even switching between like the analyst, engineering, more ML hats, and like just getting kind of comfortable jumping in and like learning as you go. And same with like, obviously not PhD political scientists or economists, but the more that like I could like peer over into those spaces and see the different ways they're talking about causal inference, or see, what I mean? Like, I think to a large extent, I think it's very good to feel like you aren't smart, because that's like tells you you're like in the right place where you're learning. Sharing on the internet, I think, is always like hard and scary. I think it is so much to the great credit to the art community that like it never felt that way. I've thought about that if I graduated, like if I'd like come into the field either like 5 years sooner or 5 years later, both of which weirdly was when the internet seems like was more hostile place. And like, ooh, what I have felt is like confident, just like putting stuff out there. But I think Emily Robinson really maybe said it best at some point in a conference talk of like, just like write for the person that like is struggling with the things you were struggling like 6 or 12 months ago, and just like try to help them know what you need to know. Because I think that's just like a good way to remember there are other people out there just working on the same stuff, and that you do like genuinely have something to contribute.
Yeah, it's such a neat way to frame it, I feel like, of just like thinking back as both a way to like really emphasize like your own growth, but also like it does feel nice to be able to just take that difference and like write it down.
Yeah. And I honestly think it's the best way to like crystallize your own thoughts. That I mean, nothing I write will ever be like, hey guys, this is exactly what I did at work today, because I'm pretty sure my employer would kind of prefer I not go like sharing IP all over the internet. But I think kind of also that just thinking about like, how would I help somebody else do this thing, forces you to actually think at the right level of abstraction. That, I mean, to just take the trivial example of column names, it's not like, it actually works better for this data set if I do this, but kind of like almost like it forces you to kind of like generate like a theory behind things that is in itself a little bit more like reusable.
I'm curious if folks have, this is maybe a tough exercise, but like things they would say to themselves from 6 to 10 months ago, 6 to 12 months ago. Like, I'm almost curious to hear what people would tell themselves.
I mean, I think I would tell myself to like try Claude Code earlier. I mean, maybe I was trying to use that like 6 months ago, but I think that is something. It does feel though like as you get further along in your career though, like you do like your growth definitely slows. Like there is that period like when you're first starting your job and there's just like this fire hose of information and everything is like, oh my God, this is like amazing. And you look back at code you wrote like 6 months ago and you're like, this is a heap of shit. Like, why would I ever write that? But certainly feels like as you're you do plateau as you get further on in your career. I guess that is more my worry now that like I am plateauing. Like when I look back at my code from a year ago, I'm like, oh, that's pretty good. Like, I don't know, that feels kind of bad. Like I should be like, oh, that's kind of shitty, Hadley. You could do way better now. But
I think for me, like, I started using coding agents basically as soon as I learned about Claude Code. I think it was in March. I think maybe was it released in February? Like it wasn't. It was definitely like beginning of this year. So there was a little bit of took a little time for me to find out about it and then start using it. But I think for a long time I held off for no particularly good reason on building like bespoke tools for myself, like essentially identifying things that like in the past, like 5 years ago, those little, I think there's even an XKCD comic about it. It's like the grid of like, is it worth coding a solution for a problem? How much time per day will it save you? And that tells you whether it's worth it. And so now with coding agents, like that whole chart needs to get completely redone because the amount of time that it takes, especially if it's building something, it's not very hard to build, but it's something that is just for you and it makes your life just a little bit better. It saves you 5 minutes a day, 10 minutes a day, maybe an hour now and then. I should have been a little bit more like I've built things in the last 3 months where I'm like, should have done this 6 months ago or a year ago. And so I think that seeing those successes has given me like a sense of like, maybe more boldness or like more of like a willingness to like dive into things or like set an agent to work building something. Like maybe it's only something, it's going to save me 10 minutes like twice a month, but whenever those 10 minutes that it saves me is going to be super satisfying. And so that's definitely changed my whole perspective on like how I do work now. So it's I think there's no way to really internalize that knowledge without going through the experience. But so I don't know if somebody like hit me over the head with that, like Wes, like build a bunch of custom tools for yourself to automate your life and your development work. If I would have believed them that it was possible 9 months ago, but I certainly believe it now.
Yeah, I mean, I hate to add to the Claude Code, but I think I'm similar. Like I think it was in a podcast with James Blair where I realized I was the only one not using Claude Code, which was a good realization. But now I'm using Claude Code a lot. But I think that the most interesting thing and surprising thing to me has been like when I watch my friends use Claude Code, I always learn new things. And so I feel like both I would tell myself to use Claude Code sooner, but also like watch people use it. Because I feel like actually with Claude Code, it's so easy to just go on your own and do stuff. But I'm endlessly surprised at how differently people approach things.
that reminds me a lot of this thing I remember, if you're a data scientist working with like someone non-technical, often the things they think are going to be really hard are often really easy, and the things they think are going to be easy are often really hard. And we're kind of in the same state with like Claude Code and these tools. We don't actually know like what is hard and easy for them, and it's so easy to like get stuck in you have to see other people do it and you're like, oh, I just assumed Claude Code could never do that, it'd be too hard for it, and then it actually turns out to be like an easy problem for it for whatever reasons. It's really like it's like fascinating learning this whole new like way of working with this like alien intelligence.
I feel like that abstracts to so many things, just like the ability to like learn from watching other people do things, which I mean is such a like hallmark too of like I think R and Python. Whereas like I think that's something I've thought about a lot. I mean, also going back to just like SQL, of like there's so much less open source SQL code on the internet because it's mostly probably like code people wrote for business applications. And like I'm always like fascinated by these weird little spaces where it's like we are like less able to like learn from one another.
It is, yeah, it's also just hard to like share. Like this is one of the things I remember when like trying to teach SQL. Like to teach it, you've got to like spin up a database. Like
Yeah.
it's like really like how do you simulate that environment? And that was definitely one of the things that always like motivated me in the design of R packages. Like how do you get people like to experience that kind of time from like downloading it to experiencing a win? And like if you have to go away and like install Postgres on your computer, then that's like a multi-day journey that involves a lot of pain and suffering. And by the time you've got that installed, you're not going to like follow through some blog post about learning some
And the
cool
way,
new
I mean, I
SQL
feel
thing.
like with art teaching, you always like drop people like directly into the analysis. Like I remember the first time I read Art for Data Science, I was like, oh, this is cool because this book isn't trying to teach me what a for loop is for the millionth time. It's fine, I get it. You're just more like, hey, like here's the diamonds data set. Let's like jump between some like wrangling and some viz and
Let's
know this viz
go.
makes us
Yeah.
ask a question. And like that too is just, I feel like it was kind of the analogous of like watching someone over the shoulder do it. Which I think can be like a really struggle earlier in your career if like you've never actually gotten to see like what good looks like. Like, how can you aspire to it?
One of the the phrases I found super useful was this idea of tacit knowledge, which I learned from Bill Bierman, who taught this like amazing data science course at Stanford that I kind of helped out with. And this idea of all of these things that like you know to do, but you'd never think to write down. And like when you watch someone working, you're like, oh my God, you can do that. Like it's fascinating. Like even, within the Tidyverse team, we've like worked very closely with each other for a long time. Like still when someone shares their screen and they do something and you're like what? I was like, what? You can right click on the positron in the dock and it lists your like recent projects. Like mind blown. Like you'd never think to write that down because it's just something you're like, oh, everyone knows this. And like seeing people like in the wild, like do analysis is really cool. It's
Oh,
really
yeah.
fun.
And I think that almost gets us back to the imposter syndrome too, of just like anything anybody can put out in the world is that like net new aha moment for someone. Like I've always felt like to the extent that I have a niche, it's just like writing about things that were like too boring or ordinary or table stakes that no one else ever bothered to like think they'd be interesting to put pen on paper on. But it is just like really satisfying when you just like find that tiny little thing that was too unimportant to say, but actually just feels so good.
Yeah, I mean, and I think that like ties kind of perfectly back to like the column selectors, which just feel like this like trivial little thing. But until people have thousands of columns in their databases, and this is actually a really painful problem. And like, let's just create like one like boring little helper that just unlocks, gets rid of all this pain.
Oh, yeah.
Yeah, I do feel like selectors too. It's the thing you appreciate when you watch someone coding and typing. You're like, this is so fast. Actually, like you kind of have to see people do it to really get just how powerful it is. But I think they're kicking us out. We're getting long in the tooth here. Emily, I appreciate so much you coming on. I feel like it's been so neat to talk about all these things and both like how you've spanned communities but also like I appreciate you surfacing the origins of selectors through Stata, and this like really important advice for people with imposter syndrome and how to just get into different areas and really like embrace discomfort and like address yourself from 6 to 12 months ago. Are we allowed to talk about Posit conf?
Yeah, sure, if Emily's okay with it.
I heard a little bird told me you might be the keynote at the next Posit conf. Is that
Yeah, I am both honored, and I told Jenny when she emailed me, right now I'm still speechless, which is probably not a good trade in keynote speaker, but
No, I'm so excited.
We're super excited to have you.
well, thank you. I'm honored. Going back to imposter syndrome, a little bit horrified, but honored
Sure,
and yeah, looking forward to the journey, because I feel like I learned so much just in the process of like bubbling my thoughts back down into words. Like I feel like the process of writing talks too, I feel like you just learn so much more about whatever it is you thought you were enough of an expert to talk about.
Yeah, 100%. Well, I feel like we're so lucky to have you at PositConf, and I'm so excited for the talk and really appreciate you coming on.
No, truly. Thank you
Mo.
all, and thanks for the great show. I'm looking forward to being back as a listener next week.
Yeah, awesome. Thanks. The Test Set is a production of Posit PBC, an open source and enterprise tooling data science software company. This episode was produced in collaboration with creative studio Agi. For more episodes, visit thetestset.co or find us on your favorite podcast platform.